It's been a big week for small language models, better known as SLMs. Microsoft led the charge with the Phi-3 family of open models, which promise developers across Azure AI, Hugging Face, Ollama and Nvidia NIM platforms the most capable and cost-effective small language model. Not 3 days later, Apple unveils OpenELM, open-source efficient language models meant for on-device tasks, and makes it available on Hugging Face AI community. Let's take a look at how these small wonders are poised to make a big impact. Why SLMs? While cloud giants like Microsoft and Google have been caught up in a race for bigger and more powerful LLMs, SLMs have quietly emerged as a force to be reckoned with. These specialized AI systems are the epitome of cost-effectiveness, accessibility, and real-time performance, making them the perfect choice for applications where speed and accuracy are paramount. SLMs have found their place in a multitude of sectors, ranging from healthcare to technology and beyond. Their application could be vast as they excel in tasks such as text summarization, generating new content, sentiment analysis, chatbots, named entity recognition, spelling correction, machine translation, and even code generation. Use cases. What truly sets SLMs apart is their ability to adapt to specific domains and tasks. They can be fine-tuned to cater to the unique needs of various industries. In the realm of healthcare, SLMs could become invaluable allies in medical diagnoses, understanding patient records, and providing relevant information. In the legal field, they could effortlessly navigate through complex jargon, contracts, and case summaries. And for coding enthusiasts, SLMs could become indispensable companions by generating code snippets, identifying errors, and assisting developers. Not only are SLMs efficient in their performance, but they also offer a cost-effective solution. They require less computational power and memory compared to their larger counterparts. This makes them ideal for on-premises and on-device deployments, enhancing security without compromising on quality. Another differentiator of SLMs lies in their platform independence given their smaller footprint. They can seamlessly transfer across platforms like Microsoft Azure, Amazon Web Services, or Google Cloud Platform. This flexibility ensures that you can harness the power of SLMs without any limitations, all while maintaining exceptional performance. Life of Phi. Onto the first of the tiny titans, Microsoft's Phi. Phi-1 delved into coding, while Phi-2 embarked on the journey of reasoning. Phi-3 has made that leap forward into incorporating both coding and reasoning proficiency. Although the Phi-3 family possesses a certain level of general knowledge, it falls short when compared to the vast breadth of information that a GPT-4 or another LLM can offer. The disparity lies in the type of answers one can obtain from an LLM trained on the entirety of the internet, as opposed to a more compact model like Phi-3. The Phi-3 family. Phi-3, developed by Microsoft, is a family of open AI models that redefine what's possible with small language models, SLMs. These models outperform others of the same size and the next size up across various language, reasoning, coding, and math benchmarks. The release of Phi-3 Mini, a 3.8 billion parameters language model, is already available on Microsoft Azure AI Studio, Hugging Face, and Ollama. Phi-3 Mini offers 2 context-length variants, 4K and 128K tokens. It's the first model in its class to support a context window of up to 128K tokens without compromising quality, surpassing both Llama 3 and Mistral Large in token capacity. Additionally, it's instruction-tuned, making it ready to use out of the box. The model is optimized for ONNX runtime, with cross-platform support across GPU, CPU, and even mobile hardware. It's also available as an Nvidia NIM microservice with a standard API interface. In fact, Microsoft has already tested Phi-3 on an iPhone, reporting satisfactory results and lightning-fast token generations, potentially bringing on-device assistants like Apple's Siri and Google Android's Gemini to new heights. In the near future, Phi-3 Small, 7 billion parameters, and Phi-3 Medium, 14 billion parameters, will be added to the Phi-3 family, providing customers with even more flexibility across the quality-cost curve. These models continue Microsoft's commitment to offering state-of-the-art small models for various applications. Everyone wants a piece of the action. Microsoft's competitors also have their own SLMs which primarily focus on simpler tasks such as document summarization or coding assistance. For instance, Google's Gemma 2 billion and 7 billion parameters have been well suited for creating basic chatbots and language-related work. Anthropic's Claude 3 Haiku is capable of reading dense research papers with graphs and providing quick summaries. More recently, Meta's released Llama 3 8 billion parameters, which has been outperforming competition and could be utilized across a range of functions. Apple joins the AI party fashionably late. As usual, Apple joins the tech innovation party in a fashionably late manner, stealing to spotlight with its announcement of OpenELM. The models offered on the open-source AI community, Hugging Face, come in various parameter versions: 270 million, 450 million, 1.1 billion, and 3 billion. Although Apple hasn't specified particular use cases for these models, they could be utilized to power assistants capable of parsing emails and texts or providing intelligent suggestions based on data. This approach is reminiscent of Google's deployment of its Gemini AI model on its Pixel smartphone lineup. The models were developed using publicly accessible datasets, and Apple is disclosing the Cornet code, the framework utilized to train OpenELM, as well as the model's recipes. Consequently, users have the opportunity to examine the construction of these models by Apple. Developers have the option to download Apple's OpenELM in either pre-trained or instruction-tuned versions. The pre-trained models serve as a foundation for users to fine-tune and develop further. On the other hand, the instruction-tuned models are already programmed to respond to instructions, making them more suitable for conversations and interactions with end users. While Apple has yet to integrate these cutting-edge AI language model capabilities into their consumer devices, rumors suggest that the upcoming iOS 18 update will introduce new AI features. These features will utilize on-device processing, ensuring user privacy without relying on cloud services. One advantage that Apple hardware holds in the realm of local AI use is its unique combination of device RAM and GPU video RAM, VRAM. This means that a Mac with 32 gigabytes of RAM can utilize it as GPU VRAM to run AI models seamlessly. In contrast, Windows devices face limitations due to separate device RAM and GPU VRAM. However, it's important to note that Apple is still catching up in terms of AI development compared to Windows/Linux. The majority of AI applications revolve around hardware designed and built by Nvidia, which Apple phased out in favor of its own chips. As a result, there is relatively less native AI development on Apple products, requiring translation layers or other complex procedures to harness the power of AI. And that wraps up our deep dive into the world of small language models. As we've seen, these models strike the perfect balance between accuracy, domain knowledge, and resource efficiency. They are not only powerful but also versatile, making them an invaluable asset in today's ever-evolving world. Thank you for joining us, and stay tuned for more exciting updates in the world of technology.